How can you get kids to read about cutting-edge research in science and engineering? Next on the K-12 Engineering Education Podcast. I'm Pius Wong in Austin, Texas. My first guest of 2022 is Tanya Dimitrova, founder and managing editor of the Science Journal for Kids, which does pretty much exactly what it sounds like. It makes real, up-to-date academic research articles in science and engineering more approachable to kids and teens. Tanya Dimitrova is a former environmental science teacher and runs this Texas-based nonprofit now. And I started off our call asking Tanya how she got all this started.
So I started Science Journal for Kids when I was working as a high school science teacher in Texas, actually right north of Austin in Georgetown. And it started as a project with my own students. Basically, I wanted them to catch up on the latest scientific discoveries in the field I was teaching, environmental science. And I made a project for them. They had to go online and pick any journal they wanted and any article they wanted within that academic journal. And just kind of read over it and introduce it to their classmates for just a few minutes to speak about the discoveries. And they totally miserably failed. And it wasn't their fault, really, because academic articles are written in something very different from regular English. And they're not written with kids in mind. So that's how I got the idea of simplifying those articles and making those discoveries accessible to students.
How old were your kids at the time, or what grade were they in?
So I taught 9th through 12th grade. Environmental science were 11th and 12th grade students.
So these were older students who were still having a lot of trouble with the academic language and jargon.
Totally. And these are students that, the next year they were going to be in university. And as part of their undergrad, they were going to read academic papers like that. And they were very unprepared for it.
Wow. Tell me a little bit about your teaching experience. I guess since you started with the origins, which is super fascinating to me, what made you want to do that project in the first place? And I guess tell me how the students failed on this project. What does that mean?
Well, to me, the impressive thing was that they had the option to pick any article they wanted, any topic that interested them personally. So it wasn't like an imposed topic from the outside that they had no background knowledge about. And even though they picked it themselves and they were interested in the topic, they just didn't understand what the academic papers really were about, let alone what the specific discoveries were. They had no clue what the scientific method was like, which could be considered a failure on my part as their teacher.
Well, maybe. But at that age, who knows? That's a whole nother discussion. But yeah.
So they just weren't able to understand and present a very brief summary of academic paper, any academic paper. And to me, that tied up the solution to this tied up well with a lot of things I had done previously before I became a teacher. I had worked as a science journalist in California, interviewing researchers, getting them to talk about their own research, and then kind of summarizing this for the readers. So this was something that came very naturally to me. And I have a science background in my education, so this seemed easy to me, and the whole adaptation seemed like a no-brainer, something I could do for my own students. And once I started doing it for my own students, and they had a light bulb moment. They were like, wow, so that's the whole thing? This is what this paper is talking about? And then I realized I could do this for more than just my class of students. I could do it for everyone.
And that was several years ago that you kind of developed the Science Journal as an official nonprofit then, right?
Yeah, that was in 2015.
And so tell me about the beginnings of that. Was it just you? Did you have people helping you translate these journal articles?
Yeah, so Science Journal for Kids is a nonprofit organization registered in Texas. And just like any organization, it started with a single person.
Yeah.
Just me doing pretty much everything. And I had a friend who did the first design because we published them as PDFs. So we keep the original structure of the academic paper, which includes an abstract, introduction, methods, results, discussion, but we also translate some of the visual materials from the original articles, maybe a results graph, a map, and so on. And all of this is arranged in a nice kid-friendly PDF. And so I had a friend of mine who did the first couple of PDFs. And then little by little, we grew as an organization. And so far, we've adapted and published over 200 papers.
Nice. Yeah. And I noticed that you have kind of a section on technology and engineering as well as all the other different science fields, whether it's environmental science or physics, anything like that. And so now your team is quite large, right? Could you tell me about what the Science Journal for Kids looks like today?
Yeah, so it started essentially focusing on environmental science because this was my specialty. Then we expanded into biology, which was the other subject I used to teach in ninth grade. And then we grew into other things as well. So physics, chemistry, technology, social sciences. So we have a lot of psychology and economics research, which is also adapted. And right now we have 5 editors, something like 10 writers who work with us, 3 designers. So it's a pretty big team, and we've grown a lot actually since the start of the pandemic.
Hmm. Yeah, I guess I should bring that up too. Does the pandemic affect any of your work? Was there a lot of interest in pandemic related science? I'm sure that it changed how you work virtually, but does it change the content of what you do at all?
Actually, it did not change the way we work whatsoever because we were
Mm,
already a remote team. Everyone was working from home. But it did change our audience a lot. So our
hmm.
audience spiked from the beginning of the pandemic, and it's been growing faster since 2020. So right now we have something like 800,000 readers annually.
You know, one of the hot topics today is all about misinformation or misunderstanding of science, especially related to epidemiology or medicine.
Yeah.
How do you feel about what you're doing? I mean, do you feel like you're making an impact on kids and maybe their parents' understanding of those kinds of things?
I certainly hope so. That's kind of what drives me to
Yeah.
continue doing what I do. Um, yes, there is a lot of misinformation out there, and specifically in response to that, we've adapted a number of papers related to COVID and infectious diseases and vaccinations and so on. Essentially, there is a lot of good information available online, a lot of reliable sources of
Hmm.
information, and just a person needs to be able to and or willing to look for it. And I think this is a big part of what we do as a journal. So as part of their school career, I believe that every student needs to start thinking about sources of information and how how scientific discoveries are made, how they're communicated, how other researchers build on top of this established body of knowledge, how science advances in incremental steps. And I think if this is all they understand from I don't know reading one of our articles, that's
Hmm.
just enough. They don't need to get all
Hmm.
the details of this one particular research paper, which may change a few years down the road. But the
Yeah.
important thing is to understand how science advances in small steps, building on previous studies and how these studies are analyzed, how the data from the study are analyzed, and how the discussion may change based on new data availability and so on.
Yeah, you're raising these issues that I think have always been a hot topic amongst the Texas teachers that I talk to anyway. Like there's that idea of kids learning science content versus learning the science process or scientific
Mm-hmm.
process. I mean, you always hear how, yeah, some students might be great at or have trouble with learning the science content, but yeah, that scientific process that you're talking about, that's the tough part. And I
Yeah,
do wonder, like,
exactly.
what do kids get from reading academic papers or reading the papers that you provide, the translations of the academic papers? What do they learn about science from all of that?
Yeah, that's a very important question because once upon a time, teachers used to be, I guess, the guardians of knowledge, right? And a teacher would enter into a classroom and their mission would be to transfer some amount of knowledge from their own head or from a book into the heads of their students. And that is not the case anymore. It cannot be the case anymore because all of the available knowledge is just one swipe away on the phone, right?
Yeah.
So the teacher's mission nowadays, a much more important mission, is to teach the students critical thinking, how to evaluate the reliability of a source of information, how to interpret data, how to interpret data presented from different data interpretations from different sources. So,
Mm.
and I hope that this is what the students will get out of reading our articles, that, there are different sections within the article. There is a section which presents the findings of the study. Well, first there is a section about describing how those findings were reached. There is a methodology section, and that's very important. Then there is a separate section for the results and a whole separate section for discussion. So these are two separate steps within the scientific process. I really want students to see this part.
Okay. Yeah, it strikes me that what you're providing, it's kind of like the cheat sheet for if you assign your own students to read an article and try to summarize it. And what are some tips that you could give to students or to teachers about, first of all, identifying some of those good scientific sources? If they had to do what you all do, like what should they look to?
So part of our job as an editorial team on Science Journal for Kids is to carefully select which papers to adapt, because there are a lot of papers published in a lot of different journals out there, and
Yeah.
not all journals are created equal. so,
Right. Right.
so being very mindful and careful about which journals to select papers from is our first step, and this is something that anybody should do in any part of their lives, right? We also very carefully select additional resources for each article that
Mhm.
we adapt, and those have to come from reputable sources, from the websites of institutions whose job is to study these things. For example, a CDC source is a lot better than some website.com or somebody's
Mhm.
personal blog, right? So probably this is the most important thing that students should be mindful of. And again, this also applies outside of academia. So
Mhm.
reading just news pieces about current events, right? So it's very important where you read those. If it's a Facebook post by some person, or if it's an
Yeah.
organization with a very clear agenda, or it's an actual reputable media source.
I'm looking at, or I did look at a lot of your articles on the Science Journal for Kids website. You have the article, just as you said, with summaries. You also have kind of like lesson plans that go with it in a way, or I don't know, stuff to help teachers incorporate it into the classroom. How do you decide on those things? How do you decide on what teaching materials to include with each of these research papers?
Well, we always look for things that would be helpful to our readers, or essentially to the teachers who want to use our articles in the classroom. And some topics, come with a very rich choice of additional teaching resources. And for some of our articles, we've actually created custom-made lesson plans, which is a lot of work.
Yeah.
That's the
Oh,
reason
yeah.
why we haven't provided it for all 200 plus of our articles. But some of them are just so much fun. So, for example, we did an article about reverse osmosis. The title is "How Can We Turn Ocean Water into Renewable Energy?" And in addition to describing the specific scientific experiment that the researchers conducted, and those are researchers from Harvard University. So, in addition to that, we created a lesson plan about hydrogen as a fuel and how it can be used to solve problems in renewable energy storage. And this lesson plan asks students to evaluate different fuel sources based on different criteria. They also get to create a fuel cell in class. So that's a really extensive lesson plan related to one of our articles.
Sounds like you want to have the students reading it kind of experience what the researchers themselves were doing. Is that kind of a fair judgment?
Yeah.
Okay.
Yeah, we do. We definitely do. And we often have we always have assessment questions after each article, but oftentimes one of the question is, how would you do this differently? Or what other research question would you ask as a follow-up study? So we definitely want the students to put themselves in the shoes of the researchers.
Yeah, that's also interesting because I do look at some of your headlines and it does make more sense why you say you can only do that for some of the articles. Because like one of them was like, how can gene editing cure disease? And I'm thinking, I don't know how much
Yeah,
the kids
don't do
can
that at
do.
home.
No, they can't do that. Okay. But that brings me to my next thought. I mean, your headlines are very distinctive and interesting. You've got short question headlines, or you basically summarize these articles, give them new titles. Like, for
Mhm.
example, how can gene editing cure disease? You have another one, how can poop be cleaned and reused? You get rid of the academic jargon with like 30 words in the title and you try to make it sounds like you condense it for K through 12 students. What goes into making those short headlines? Do we lose anything? Do we gain something when you do that?
Well, hopefully we gain clarity because essentially what we try to do is summarize the research question driving the original research into a very kid-friendly language. And we try not to have yes/no questions as a title
Mm,
because those are boring. So
yeah.
we have a lot of how and why questions.
That's interesting because there. I don't know if you're aware of the Tumble podcast.
Mm-hmm.
I spoke to Marshall Escamilla, who made that podcast for kids, where they talk about science topics, and he and his team, they titled their episodes with a question as well.
Yeah, Tumble is a really cool platform. They actually did an interview with one of our researchers slash writers who was 12 at the time.
Oh wow!
Sarah Galvani Townsend. Yes, she's both of her parents are researchers at Yale, and she actually participated in some of their research. She did a couple of papers for us, one on HIV and the other one on rabies. So rabies spread in India and how it can be prevented. So we also try to involve young people in the adaptation process.
Hmm. How do you do that?
So Sarah was one example. She was actually one of our writers because she understood the research written by her mother very well,
Hmm.
and she adapted it and she just wrote the kid friendly article for us. And then
Wow.
we edited it and published it and so on. Another way we try to involve young people who are the ultimate readers of our research is to solicit ideas about articles, specific papers that we should adapt, and
Hmm.
topics that are interesting to them. And this has been really cool because, like I said, we started from a topic that I personally was very familiar with, environmental science and
Yeah.
biology. And now we're spreading into other fields, astronomy, gene editing, and a lot of interesting topics are coming out as suggestions from students.
That's cool. You're very much demonstrating that engineering idea of designing your product toward your audience or your users or your customers. And so I like that you're kind of gearing it towards what kids seem to be showing interest in. And that brings me to the question, what are some of the hot topics that kids or young people are interested in today? I don't know if they're interested in the pandemic. I know that's just a hot topic, but are there other things that really provoke students to be into science and engineering right now?
Well, frankly, I think both students and adults are a bit tired of
Hmm.
epidemiological topics, and
Yeah, yeah, I get it.
I completely get it. Yeah, but okay, let me share some topics that were recently suggested by
Sure,
students. Let me just open up a little list that I have.
sure. That's cool. Like you have like the top 10 most recent.
But yeah, this is something completely new to us, soliciting topic ideas from students, and I'm really excited about it. So I'm happy to share.
Sure. Yeah.
Let's see. Okay, so some topics that students have brought up: astrophysics and astroengineering. So engineering for space flight. Another one is computer science and specifically AI, so artificial intelligence development, space exploration coming up again, renewable energy, genetics and engineering.
Hmm.
Another very interesting topic: environmental sustainability and environmental justice.
Hmm. Hmm. This jives with, say, what I'm seeing in media too, in the movies and in news.
Yeah, I think so. It's and we're actually just starting work on adapting a paper about growing lettuce on the ISS
Oh wow. Yeah.
in the veggie experiment. So
Yeah.
so
Yeah.
this came out straight from a student suggestion. Others are things like drug development, mental health,
Hmm.
developmental biology, and stem cells is another topic.
They're on the
Which is
cutting
highlighted.
edge. Every single thing you're mentioning is like stuff that I want to know more about, but know nothing about it in some ways.
It's true, and I feel that genetic engineering to to the current students' generation is what computer science was to a generation, I don't know, 15 years ago.
Mm-hmm.
15, 20 years ago, everybody was talking about, students need to learn to code, and they still do. But now we're talking about students learning how to reprogram the genetic code.
Yeah, it's interesting because I only learned of you and the Scientific Journal for Kids from actually my last podcast guest, who was kind of a he was a lot of things. He was a biologist and an engineer, electrical engineer, but basically, he was working on making biomolecular circuits. I guess little machines made out of biological molecules to do what you were saying, for
Hmm.
example, edit genes, but even more than that, I guess he's saying you can control you can deliver medicines to small parts of your body, just all sorts of things. It sounds like making
Hmm.
computers with biology.
Yeah, and it seems that students are picking up on that, at least the more perceptive ones.
Hmm.
Another thing that was readers suggested that we kind of pivoted to was trying to connect the students, the readers, with the original researchers in a more direct way, not just through the text of the translated text of their research, but actually having the students ask questions of the researchers.
Hmm.
So now we've opened up our platform to receive questions, video recorded questions from students, and then we forward those to the researchers, and they video record their own responses, and then we produce the video together and we post it on social media.
That's really cool. So, do you work with all the researchers who you end up translating articles for?
Yes, essentially, they're all interested in science communication and communicating their research better. So that's why they signed up for working with us. So they're all super excited to get questions from students. It's just the highlight of their day.
Yeah. Do you feel that you have to create different versions of your articles for young students versus old students, say elementary school versus your old high school students?
Yeah, for sure. So we categorize all of our articles in four broad categories: elementary school, middle school, lower high school, and upper high school. And sometimes an article can fall in, let's say, two of those categories, middle school and lower high school. All of our articles fall in one of these categories. And sometimes we even produce two different reading levels for each article. So let's say one which is middle school and one which is upper high school, containing essentially the same information, but just one is written in a little bit more simplified language than the other.
Is it harder to write for young kids or old kids? I'm imagining if you had to write an article about astrophysics, do you include more complex? Like, I'm trying to think what's harder. I feel like both have their challenges.
They both have their challenges, but I think it depends on two other things. It depends on the type of research. Some research is inherently very complex, and the reader has to have some basic knowledge that, say, an elementary school student just doesn't have yet. And the other thing is that we have to take into consideration is how comfortable the researchers are in getting their research simplified. Because we collaborate directly with the researchers and they approve every single article that we've ever published. So they have to be, and their name is still on it. It's still their research, just we've translated it. So they have to be comfortable with the level of simplification that we offer. And some researchers are perfectly happy to have the article adapted for upper high school and no lower than that. And others are really happy to lose a lot of the detail in order to be able to reach, say, elementary school students.
If you're familiar with Reddit, there's a subreddit called Explain Like I'm 5, I think, or something like that. And so I guess I could see that. Like, what kinds of fields are some of those inherently more difficult ones where you couldn't explain it to someone who's 5?
Great question. So I think the one that you mentioned, gene editing, and so a lot of gene editing articles are, like I said, the reader needs some basic background knowledge. They need to know what genes are, and we could just focus on explaining what a gene is. But
then it's not. Right,
but then it's not a summary,
yeah.
Right? It's not the research.
Got it.
There are a lot of cutting edge technology articles that are also a bit too complicated to adapt. So, for example, using electronic chips to simulate some more complicated processes, or we have one about quantum computers. So just having to explain what quantum physics is, we are limited to the amount of simplification we can make.
Yeah, I see that when it gets too abstract, it's probably not as worth it.
Yeah, but others are still others were still able to simplify them a lot. So, for example, we did one about analyzing ancient DNA found in ancient mummified Egyptian people. So even if the students don't get all the details about the DNA analysis and the extraction of the material and so on, just being able to understand that, hey, we modern people are able to get to understand something scientifically about the biology of people who lived 4,000 years ago. Just getting this idea out of reading our article, that's enough for me.
Yeah, and it's funny that that's a DNA related article, yet you can still translate that for young folks.
Yeah.
And it makes me think about more than just the language that you're translating. You said that back when you founded the journal, you had someone help you with the visuals too. What goes into translating those? Do you change visuals at all to make it more kid-friendly?
Yeah, we work very hard on the visuals, making sure that that the resulting PDF is not scary and it doesn't make you automatically avert your eyes away from it.
Yeah. No, and because I'm thinking about DNA graphs that I've seen before where you're seeing like pictures of I don't even know, like what's it called? Those things that filter down and you see the lines. This is how bad I am with it right now. But like all these diagrams and graphs and tables, like what are the ways, I guess, the tips and tricks of condensing those?
Yeah, so we try to be as creative as possible. So, for example, this article that I just mentioned about the ancient Egyptian DNA analysis. So we used to give an example of how ancient DNA gets fractured, and then we analyze just fragments that we find, we used little pieces of paper with parts of a sentence on them. Just so imagining that the DNA code is a full sentence,
Yeah, yeah.
and the sentence, for example, is the inhabitants of the ancient Egypt relied on the Nile floods. And then we have 8 different small pieces of paper drawn, and each one of them has a little section of the sentence, but not a full word, just a few letters from the third word and then the fourth word and so on, and just trying to piece those together. And this is very much analogous to the analysis process that ancient DNA goes through.
That's
so
cool.
this is one way. This is one way. Another thing that we do is we always try to so when we do, let's say, a scientific graph with the results, be it a bar graph or a pie chart or anything like that, we always try to convey a single message, to show a single trend. Because originally published research, the researchers try to fit as much results, as much findings as possible into a single graph.
Yeah.
There are multiple different variables indicated by the legend, different colors, different lines. It's pretty busy, to say the least. So we always negotiate very hard with our researchers to try to boil this down to the most important message of this graph. We cannot and we do not try to show all of the results in a single graph. We pick one of them and use the graph as an example of how to show scientific results graphically. Say a simple pie chart showing just one trend.
Mm-hmm.
And every graph comes with a takeaway question, just essentially, okay, looking at this graph, for example, which type of sample had the most identified sources of DNA? This is from the ancient Egyptian article. So the student can really take a look and try to figure out what is the simple message of this graph, and by answering this question.
They can have their own analysis experience, feel like a scientist a little bit in some way.
Yeah, exactly.
Mm-hmm. It makes me wonder, like, because you're making these summaries, and maybe other science journalists have this issue too, are there any issues with like copyright, I guess, or people caring about plagiarism? It's not plagiarism because you're not copying them, but how does that factor into what you do? Do people care about any of that?
So our content license for everything that we publish is CC BY, so Creative Commons Attribution, and it's open to download and reuse and modify however readers like. And we try to only select papers which are open access, so they have the same content license, though. This is not always possible. So sometimes we adapt papers which are copyrighted by, let's say, the journal Nature, the journal Science, and so on. Yeah. But we are a non-profit organization and our product is non-commercial. So this is considered fair use of their copyright. And it's for educational purposes. And again, those resources are not sold. So, and we work with the original authors, with the original researchers. So this is not an issue for us.
That's great for teachers. Teachers are always, told, hey, well, I don't know how much teachers pay attention to copyright all the time because I know the photocopier is used. I use it a lot, but for sure, that's what districts want to know, that it's safe to use. And I guess speaking of how teachers might use your resources, I mentioned how I liked some of the lesson plans and those reflection questions you always include. Do you have a need to align your work with standards, stuff like that?
Yeah, we've received feedback from teachers that this is very, very important and very helpful. So all of our articles are aligned with the NGSS, so the next generation standards, the national standards. And those that are related to environmental science are also aligned with AP environmental science curriculum. The biology papers are aligned with the IB biology curriculum. And we're also looking for, possibly aligning them to some state standards. But, with so many states, so many different standards, it's a
That's a
bit
lot
more
of work.
challenging.
Yeah.
If there's one thing that I would kind of recommend to teachers using our website, is to give students choice. So we have so many articles that we've published from different fields, different reading levels, and so on, that I think it would be really valuable if students came to our website themselves and picked the paper that they wanted to read. In my experience, students really work best when they have a choice in selecting the topic or selecting the article they're going to read. So maybe that's one tip that I provide.
If you had your resource back when you were teaching in Texas, how would that have changed what you did in your environmental science class?
Great question. So I think a lot of people already agree that project-based learning works really well when students are working on something meaningful, something that in which they create some resource. So that would be one thing. I'd have my students pick one of those articles and then read through it, and then try maybe to do a replication study, if it's at all possible, or a follow-up study. Another thing that I have used this website for with my own students is using these adapted articles as a model for how to write up their own scientific lab reports. So after we've done a lab in class, or in the lab, and they have to write up their own results, this is a model for the exact format that I want them to use. Introduction, methods, results, discussion. This is another useful thing.
Okay. Yeah, that's a good idea. It reminded me of what teachers said, even for their engineering classes, because there is often a struggle to get their engineering students to document their work appropriately and present it to other people appropriately. I don't know if that's a thing just with engineering students. That's the stereotype that they need to improve their communication.
I think that's for everyone.
Is it
It's not
everyone?
just yeah, I think so. It's not just engineering students. Again, this is a different way of that's a different format of writing, right?
Yeah.
So you have to take very good notes during your lab work, and then you have to think about how to write your notes up and your findings up, and you really have to think in sections. That's why I keep referring back to this, because it's so important. When you say something, you have to, or when you write a sentence, you have to think, where does this sentence belong? Is that my interpretation of the data? In that case, it goes in the discussion. Does it provide background about this scientific experiment? In that case, it goes in the introduction section. Is that stating the result or the data that we collected? In that case, it goes in the results section. And it's very important to be able to think in such a structured way.
Do you find, well, this is kind of an odd question because I'll just preface it that way. But do you find that when you create a piece of writing, it might be like creating a physical product? Like when engineers design something, they have to have a structured way of thinking about it. Every part has to be connected to something else in some way. I don't know, the way you talk about structuring or designing or writing an article, you're saying you aren't just like throwing whatever you want on the page. You're really following a kind of process.
I like this comparison a lot. So yes, I've been working with texts for a long time now. Before being a teacher, I was a journalist. And yes, indeed, when you are writing up a text, you want to make sure that every sentence is structured well, that every sentence relates well to the previous or the next sentence, that every paragraph or section within the text starts with a clear understanding of what this paragraph is about. And I actually write these in the margins when I'm writing or editing a text. I'm like, okay, this paragraph describes step one of the method. So we don't want any information that does not belong here. Or we don't want to repeat something both here and in the next paragraph, and so on. So trying to be as clear as possible with the text, I think, is very important, especially given how much information we're bombarded with every day. We all, not just the students, we all have a very limited attention span. So we want to be gentle to our readers.
No, and I'm sure they appreciate that. It's cool that you mention all the other things that go into writing an article that people might not necessarily see.
Yeah.
I just want to mention one other thing I thought was cool for teachers in the Science Journal for Kids website is you also have these profiles of professionals, of scientists, of engineers, people working in the field. And the reason why I like it is there's a need for students to be able to see themselves, I guess, in the field. Can you tell me a little bit about why you have those profiles up there and just who you get on there, how that all works?
Yeah, this is a very important, I think, part of our work. As the saying goes, students cannot be what they cannot see, right? So we try to work with an as diverse group of researchers as possible, as opposed to just working with researchers from a specific gender or race or a specific set of universities or even a specific country. So we have we have worked with researchers from all around the world, and this, by the way, can be seen on a map on our website where the readers can pick on the map. They could pick where do they want the research to come out of, where in the world. So that's step number one, trying to work with diverse researchers. Step number two is to really meet the readers and the researchers. And like I said earlier, now we're trying to do this with video questions and video responses recorded by the researchers. And this is actually version 2 of what you just identified. So we started off by writing profiles and just written interviews with some of our researchers. And the feedback that we got from readers is that we don't want to read anymore. We want to watch those.
Yeah. Sure.
So that's kind of why we moved away from the written profiles and more towards video interactions, not in real time. So in those video interactions, we always try to feature researchers from underrepresented groups, exactly for the purpose of, making all students welcome in science and making them all feel like they can belong if that's what they're interested in. And I have one really favorite quote from one of those interviews that I'm going to open up right now and read for you. So the researcher who said this is Dr. Shannon Curie from the Max Planck Institute in Germany, and she works with bats. She's an animal physiologist. She studies bat metabolism. So she said the following. She said, "My advice for all potential students, but particularly young people from minority groups, try not to let anyone derail you from your path by asking you questions like, 'Are you sure?' This is a very good question in science, and you should do your research, but often this question is asked when you are at a career-defining moment. Are you sure you want to enter science? Or are you sure you want to get a PhD? The more weight you give to this question, the more likely you are to let it drive you away from this path. And it is asked to those in minority groups more often than others." So that's one of the things we try to make our readers cognizant of and aware of, that the scientific field is open to anyone and is suitable for anyone who is curious and interested to learn how the world works and has, I guess, enough discipline to do the hard work of actually diving deep into a particular topic and really studying hard for a certain amount of time, and then just being diligent in using the scientific method and being ethical and careful not to overinterpret data from future experiments. And well, there's so much that goes into being a scientist, but it's it's a completely possible career field for anyone.
I think that's a great place to try to wrap up. Are there any other big plans for this year, 2022, that we should know about besides engaging with readers more, putting up those videos? Anything else you want to share?
We're always open to feedback, and as a small organization, we pivot pretty quickly based on readers' feedback. But one thing that we'd like to do, a couple of things that we'd like to do this year is first get onto some more social media platforms that are more younger audiences friendly,
TikTok,
TikTok and Snapchat and so on, which is a whole new kind of field for us to explore. And another thing is, so we've started, again, based on readers' feedback, we've started providing audio versions of all of our articles. So basically, someone reading the article and recording this and providing it as an audio recording. For students who have difficulties reading or English is not their first language or and so on. And these right now are on YouTube. The reader can watch the article being scrolled on the screen and then listen to it being read.
That's cool.
But we would also like to upload those audio recordings as an audio podcast.
Yeah, that was going to be my next question, but hey, I'll look out for that. That's awesome.
Yeah.
And so how do teachers, how do scientists and people find out more about the YouTube channel and just everything about the Science Journal for Kids?
So just go to the website, sciencejournalforkids.org, and browse the articles that we have, search them based on any criteria. We have collections for different class subjects, for example, for biology or environmental science or chemistry and so on. Again, they could browse by research location, by university, by research method, and so on. And then pick the articles that you're interested in. And then each article comes with a bunch of additional resources. For example, an audio version or additional lessons and so on. I think that's the best way. We are on all the social media platforms as well, but a good place to start is our website.
Awesome. Tanya, thank you so much for talking for such a long time with me. I really appreciate it. It's really great what you do, and I'll be following up your growth.
It was my pleasure, and thank you for the invitation.
That was Tanya Dimitrova, Managing Editor of the Science Journal for Kids. Check the show notes for links to a lot of what came up today. You can also just go on your browser to the podcast website, k12engineering.net. The K-12 Engineering Education Podcast is produced by my indie studio, Pios Labs, in Austin, Texas. Pios Labs fosters growth in engineering and education through edtech, digital media, games, and professional development. Follow Pios Labs everywhere to stay updated. That's Pios Labs. What do you think of the talk this episode? Let me know by leaving a rating and a review wherever you're listening. It's a huge free boost for the show when you do. Thanks again to the boss patrons of this show on Patreon. You can donate to the show too, which lets me keep it up on the internet. Go to patreon.com/PiosLabs. That's patreon.com/PiosLabs. Okay, take care, listener, and catch you next time.